Hi folks, in this video I'll demonstrate how to get started with Python. So let me open a terminal in VS Code. There should be a Python installed on your host machine, but since we already know how to use containers, and containers is a good way to encapsulate another environment, so we can bring in another Python environment. So here's a .compose. We're going to bring in an image with Python 3.9.5 installed, and then we're going to map our host files. Right now there's nothing, but if we start adding Python files, they'll show up in the container, and then we'll just say when the container starts up, we want to be in this folder. And this is just a very conventional folder that I've seen used within containers on the internet or images on the internet. So nothing special about this path. You can make it anything. All right, so we don't want to pollute the host, and so we're going to drop into our container now and use the containers Python. And if you've seen stuff like Anaconda, mini condo or condo, those are another ways to kind of control your environment to be able to support multiple versions of Python and libraries. Some of them have extra stuff related with data science, but containers can help us with the multiple versions of Python portion. All right, so let's run our Python demo container, and we'll drop into the shell. Okay, now that we're in the path that we wanted, and in that path we see our Docker Compose file. So in this container, we have our 3.9 version compared to our so 3.9 as opposed to the host 2.7. Okay, so there's two ways to run Python. One is through the interactive read eval print loop, the REPL. And to drop into that, let's do this, and any Python commands you put, it'll work. It'll feed back to you. But this is useful for testing out simple commands. But once you have a bunch of commands, it gets hard to use that. So what we're going to do is create a Python file. The convention is .py extension, but you might be able to use another extension if you choose, but sticking to conventions would be helpful. So we see that within our container, this file shows up as well. So let's do that. And if we were to run, that would work. And if we just want to test the file extension, it still works. Some parts might break down, but yeah, I would still just use the .py extension. All right, so let's go through some basic Python features. So on our website, go to the Python section. So here are some basics. I won't go through all of them exactly the same way. Um, I'll just highlight the stuff that uh, I typically ran into, and I'll leave the other tidbits for you to go through on your own. All right, so let's start with variables. So Python, we don't really have to declare any types, for better or for worse, right? Depending, yeah. Some people like type, some people don't. So we were to run this. Oh, forgot to save. Okay. And of course, our string. Okay. String works as you expect. In Python, arrays are referred to as lists. And again, square brackets. And you can mix. What's in the list? They also have, let's see, did you go through it? They have these things called sets, which is pretty useful. So similar to this, but they're intended for having no duplicate entries. So if we run, you notice we can have a duplicate of the 1. For the set, we can, it should make it, force everything to be unique. Sorry about that. So here, even though we have 1 twice, it only shows up once. Okay. Says do not allow duplicates. Let's allow duplicates. So that's kind of a one of the feature different, one of the differences. There's probably other things that I'm not aware of. All right, so the next one is dictionaries, which is equivalent to JavaScript's object. Some languages call them hash or hash maps. So in Python, is called Dictionaries, and use the curly braces just like in JavaScript we did. And again, you need a key. Forgot their syntax. Yes, colon. Value. We can use a variable, like the string variable. Print that out. And here, the string is used as the key, and then is also used as the value. Okay, I think that highlights most of the common variables. I probably won't get into too much of the advanced um, Python stuff. List comprehensions are pretty Pythonic. Is something that a lot of Python people use. I guess they're called Pythonistas. Very idiomatic to the language. But you can read up on that. So let's go over to um, flow controls. Okay. This time we'll copy over our list and dictionary, but we don't need to print it out. And then we're to run this new file. Well, I should do this. Oh, we didn't define our string variable. That's okay. We'll just hard code it. Okay, we're defining and assigning the variable, but we're never using it. So, all right, so let's use it now. First one is some if-else. I guess we should also put in a number variable. So here's our basic if-else branching. So if number variable is greater than 3, greater, you can also check if a key is inside, or an element is inside a list. Okay, so that's if. There's our else. Greater. Lesser. I'm not sure if that's proper English. Okay, so you notice that um, there's no more parentheses. Uh, we use these colons in Python, and we use spaces or tabs. Um, and be very careful on your spaces and tabs because they can produce errors. Uh, okay, and like I said, I don't need semicolons either. So if you're off by a space, it will break. Uh, so please be mindful of your spaces and tabs. My recommendation is to use spaces and configure your editor to um, substitute any tabs with spaces, and you can set up to 2 or 4. I prefer 2, but in Python, the community always tends to go 4. So if you do use 4, you know, that's up to you. Um, 4 just makes me easier for me to code review. 2 just makes it easier for me to code review without actually running everyone's code. All right, and then if you can also, there's this thing called pass. Uh, it allows you to kind of like do nothing, because if you try to just have it like that, it's expecting something. So if you're troubleshooting, you can just put a pass to kind of get you going. Okay, but okay. So that's the branching. Let's do looping. So here, do a we'll loop through the arrays. List item in list variable, and we'll just print it out. Okay, so here's our list variable, and we're just printing it out. I like the for loops better. They just have more. I tend to use them more often. If you need a while loop to do something until something happens, uh, you can do that. Like for instance, there's a way to just generate a list go from 0 to 5. So I do prefer that um, over doing the while and then creating your own counters. Though I would use while if there's a flag to kind of break the loop. And again, um, break and continue works for looping if you need to stop the looping. So There's also an else, but I don't tend to use those too often. Yeah, so I guess if you do break, you can. If you do break out of a loop, wait, this happens at the end. This is not because of break. Let's just give that a shot. Let's break. Oop. Got my colon there. So if it broke, it doesn't finish. It doesn't jump get to the else. But if it finishes, it'll get to the else. So that might be useful for certain things. And then the other, let's do the same thing, but for the dictionary. And then, sorry about that. So now dictionary, and then we'll just bring that. Oops, I added an extra S. I should fix that. Okay, let's do that. And here we're looping through. So let's clarify between the two. All right, so this other type of loop I've been finding very useful. Loop with the index. So how you would do that is you use this enumerate, and there's options you can pass to enumerate. And then do this. And we'll print that out. Oop, my fingers are really fat today. What did I do? Oh, it's an integer. I think you just cast it to a string. Oops, just that. Unlike JavaScript, it's not going to cast for you. Oh. we have an integer in our list as well. Okay. What did I do wrong here? Oh yeah, sorry. There it is. That's the index, and that's the element. Guess I can make it more clear. Int and string. Oh, how did I lose that? Did it do? Okay, so here's the index, and here's the string. Okay, let's do the same thing for our dictionary. But for dictionaries, you don't really have an index. It's more of a, you want the key and the value. So I think we'll just find that syntax. Let's see, loop with key value. Here you go, key and value. So we say dict key and value, and then it would do something like this. Print out the key, label as key, print out the value, print out, label it as the value, and then let's fix this up here, and we'll call this value instead. Oh, we also need to go items. So here you go. We are able to loop through and get the key and the value. So I should actually put them, okay, compare them side by side or one after the other. List with index. dictionary with key. And where are we at? Yes, we wanted to call this value. Okay, now if we were to run it, so comparing the two ways of doing the list, one we're able to get to the index and the other not, and looping through the dictionary, one we're able to get to the keys or the value, and the other one you're not. The other way we could have done it is could have done dict variable, and then here we're printing out the values. So you could accomplish the same thing. I think one syntax is just nicer than the other. Oh yeah, so I should also go over accessing. I guess it should be over here. So if we were to print out, we want to get to the word to, we can access it using square braces, and it is zero index. So we let's see. Yep. So here's the two, and I'm not sure if it's the same way. Let's try a different one. 0, 1. So the third element, or the 0, the element with the index of 2. Yeah. Let's see. Because it's unique, it's no longer ordered. I don't know. It would make sense to do it that way. Definitely can't use an index because it's not ordered. So it's really just to check if it exists or not. So I think this is probably the most common use case. 2, and I'll set variable, and it's true. And then if we were to change it to 3, it'll be false. So that's most likely how you would actually interact with a set. And then for our dictionary, again, we use curly braces. Square brackets. And then the string of our key. So here's the value. That's corresponding to the key that we're looking for. I guess if you really wanted to, you can do high from string as well. And that'll give us our value 2 from the high from string. Alright, so I think this makes the most sense. Okay, so that's our looping. Let's move on to our functions now. Create a new file. Okay. So this is what we're going to do. Define simple function. Let's see. I was just looking at the casing. So here they use snake casing. And we've been using camel case. So casing is something to be aware of. I might have used the wrong casing in this example here. So please forgive me. That's how you define a function, and then you can call a function after you've defined it. Oh, we need to give it. Okay, so that's how you define and use a function. Don't forget the curly braces. You can also add arguments to the function. Apologize for that. So there you go. It'll print out the argument to us. It can be a string if you want. It can even be a list. Or a dictionary. Okay, All that is possible. You can also return from the function, and then whatever is returned, you can save it in a variable. So I won't go through that. Again, you can use pass. Okay, let's move on to classes. And to do that, let's create a new file. We'll define a class called simple class. And then we'll define a function to call when we initialize the class. And here, self will refer to the instance of the class. So again, this is object-oriented programming here. You have a blueprint of an object. Each time you create an instance of the object based on that blueprint, that instance has its own variables. So that's what the self is here. So we can pass it first argument and then save what's been passed in to the instance of the class. So this is what you call an instance variable, and set that to what we passed in. And let's just see if that worked. And classes. Okay, no errors. So let's define a public method for this class. So this will be an instance method. Let's see. Let's just do that. And then we gotta say pass in the self. And then we'll just print out from method self instance variable, and we'll return done. Return value. Okay, so now we actually have to use the class. So we're to use it, we'll say simple class, give it a string passed in, and then we can call our instance method on that. Class. So here this is coming from inside, and if we were to print out the return value of that method, it'll be something like that. So more typically, you'll actually save the class instance 1 is equal to simple class, pass in our argument, and then if we then call instance method on our first instance, we have 1. And if we were to do it with 2 and saved it off as 2, let's do that. We'll print them all at the same time. We'll see 1 and 2. Okay. Let's see. So let's talk about class variables a bit. If we were to, I think this one has this in it, this example code. So we'll say this is a, I think it's a class variable. If we were to print each time, okay, guess we still need the self. So this is available in both classes. So let's do something to modify variables. We'll give it an argument. Let's see. New. And then okay. So if we then modify it, I'll make it singular, and we'll say new 1, new 2, and then if we were to print it again, we'll have our updated variable printed. And so here's the part that might or might not work here. So let's try, see if this works again. Okay, and then let's see if we can do this. Try to modify our class variable. See if it affects both classes or not, or both instances. Class variable. Let's do it to just class instance 1. new any number. Oops. Oh, there we go. So the arrow's on line 933, or close to it. Wow. So you actually cannot change any of the class variables. Or, yeah, so that makes sense. There's probably a way maybe to do it, but it does kind of shelter the class variables from being modified. Okay, so that's that. And I guess since we talked about class variables, we should do a class method as well. I hope this works. So let's do our simple class, and then see if we can call our class method. Yeah, so here's our class method, and then see if our class instance has access to this class method. Yeah, so I think you needed to provide that self. So yeah, it works kind of very intuitively. This won't work. Let's be more specific here. Calling a class method from a class instance will not work. All right, so that's probably all I want to say about classes. And the next part is how do you reuse classes? So let's create another one. Reusable classes, and we'll just take this very simplistic portion of it. Reusable class. We don't need a variable here. I guess we just not define it either. So here's our class, and if we actually had a main function, and we try to use our class the same way. Oh, not here. All right. Here's our main. There's our class. So reusable class. We don't pass it any arguments. Reusable class. So we do Python. Oh, yeah. Python main. So not defined. We'll need to import our class from this file. So from reusable classes, import reusable class. Now if we were to run it, it doesn't error out. So let's move this back here. So we are able to create the class and oh yeah, we actually want the instance method. Not the class method. And then in our main, let's give this some more space here. In our main, I guess we can get rid of these files. I'm not sure why it's doing that scrolling thing. Okay, so we imported it. We made an instance of it, and now we should be able to call its instance method. Oh, we don't need to create an instance variable for this example. But if you wanted to, you can make this reusable class look like our simple class. So here, we're able to reuse a class from a different file. If you do decide to organize it, in a folder, let's see, we're then move this into that folder. It should break because it can no longer find it. So you just need to tell it to go reusables dot. And I think here I might use, so it's able to find that folder and then find the file and then find the class within that file. So that's how you can organize your files. So I think, I forget the terminology, but one is a package and one is a module. I forgot if folders were packages and files were modules, but I'm sure you can Google that. And I'm not sure if I'm saying anything wrong there. Okay, so the last thing is we just went through how to reuse files, classes, and code from within our project, so things that we control. If we were to use another library controlled, so Numpy is another library, and if we wanted to use Numpy is a great computer science library. Sorry, not computer science. Machine learning, data analytics library. It allows you to do things like array matrix operations. So yeah, this is not too great. Let's just go to NumPy's documentation. Their quick start. So yeah, NumPy offers a matrix manipulation, matrix math. So we were to just try to do this, or we will try to import NumPy as pi. So we should always put our imports in top. This should error out because we don't have NumPy installed. So in order to install it, there's this command line tool called pip. So we do pip install NumPy. It will install it for us within our container. Of course, when the container ends, NumPy will be gone as well. But we can set up our containers to kind of save that, which we won't go through here. We will go through it a little bit later. And another thing that pip uses is a requirements.txt file. So you can save all your dependencies in that file and share it as code, and then pip is able to recognize it. So now pip's done installing NumPy. We can run our code again. There's no error because this package actually exists. And if we were to do something simple, let me just give a brief overview of NumPy. So here we print out what NumPy gives us. It's just an array going from with 15 sequential integers. You can then reshape it into a matrix. 3 by 5 or 5 by 3, I forget the terminology. I'll break it up into, again, I don't know if these are columns or rows, but yeah, then you can do like multiplication, matrix multiplication, or other sort of matrix manipulation. But that's probably all I'll go into for here. If you do need to analyze number, look into NumPy, SciPy. There's a whole bunch of other libraries that Python has to allow for data science. Yeah, not computer science, data science. Sorry, that's the word I was looking for. All right, I think that's all I have in regards to Python. So again, when we did the pip install, it only installed within the container. So our host is still still pristine. If we exit out the container, yeah, Python's not even installed on the host. Not Python. No, pip's not installed on the host. And if we were to go back into the container, you'll notice that NumPy is no longer in the container. So just be mindful of that. There is ways to get around it using container volumes and such, but that's not that. We'll go through that another time. Okay, so that's Python. Hopefully that works. And yeah, good luck and have fun.